Dear students, in the class we are going to discuss the solving that first order partial differential equation, what is called Lagrange's linear equation. What is called that the Lagrange's linear equation, the equation of the form the equation of the form PP plus Q, capital Q small q equal to R, capital P into small p plus capital Q into small q equal to capital R. We know that here P and small q are the first order partial derivatives. First order partial derivatives. Then this is equation number 1. The equation 1 is called Lagrange's linear equation. So here the capital P, capital Q and the capital R are the functions of x, y and z. Sometimes it may be the constants. So here that P, already we have discussed when we are solving that pi of u comma v equal to 0, where u is the function of x, y, z, v is the function of x, y, z. When you are eliminating that arbitrary function, you will get that the equation in the format of capital P, small p, capital Q, small q equal to capital R. So what is P here? P is the tau of x comma y by tau of y comma z. Q is tau of q comma v divided by tau of z comma x, and then R is the Jacobian tau of u comma v divided by tau of z comma x, not z comma x actually, x comma y, erased, z comma x is x comma y. I am repeating that second one. It's not correct. We have to correct it. So to solve this equation, to solve the equation 1, that is Lagrange's linear equation capital P small capital Q small q equal to R, it is enough to solve the subsidiary equation or auxiliary equation the subsidiary equation is in the form of dx by capital P, dy by capital Q, dz by capital R. There are two types of there to solving this subsidiary equation. So always the subsidiary equation contains three terms. This is the first term, second term, it is the third term. So what is a working rule for solving this? Working rule to solve this subsidiary equation. So first step is working rule to solve that BP is Q equal to R. What is the first step? First step is write down the subsidiary equation. Write down the subsidiary equation. What is the subsidiary equation here? Dx by P equal to dy by Q dz by R. That is the first step. Second step is we have to solve the above subsidiary equation. Solve the subsidiary equation. We will get the two solutions. The two solutions is like u equal to C1 and v equal to C2. So let the two solutions be u equal to C1, v equal to C2. Then third step is then you have to write that f of u comma v equal to 0 or u equal to either you can write that pi of v, u equal to pi of v, so it is a required solution. It's a required solution of BP equal to R. So there are two ways to solve the subsidiary equations. So the subsidiary equations can be solved in two ways. The first one is method of grouping. The second one is method of multipliers. When you have to use that method of grouping, when you have to use that method of multipliers. Case that is few things you need to know. In case when you are eliminating that arbitrary function pi of u comma v equal to 0, then you will get the solution. When you are eliminating that arbitrary function, you will get the solution in the format of capital P, small p, capital Q, small q equal to, or we know that the capital P, capital Q, capital R are that functions of are the functions of xy z, and a constant also sometimes. Okay, so what is the general format of PP plus QQ equal to R Lagrange's linear equation? This Lagrange's linear equation may be written as xp plus yq equal to z. So this is also in the format of PP plus QQ equal to R. Otherwise, xyp plus yzq equal to zx. You can write like this also. Even we can write that functions of x, y, z can be written like that: x plus y p plus y plus z q equal to z plus x. So what is the difference between these two equations? Equation number 1 and equation number 2. What is the difference between these two equations? You can see that P, capital P, is for equation number 1. Capital P is xy, capital Q is yz, capital R is zx. But for the second equation, capital P is x plus y, capital Q equal to y plus z, capital R equal to z plus x. Here we can observe one thing: all that x, y, z in that multiplication form. That is x and y in multiplication, y and z is in multiplication, z and x in multiplication. Even it may be like that x by y by z, or z by x. Multiplication or division, we can use that method of grouping. We can use the method of grouping. Please keep it in mind. In case that p, q, r are the function of x, y, z, x, y, z are in the multiplication format, we can use that method of grouping. Otherwise, in case if it is in the addition or subtraction format, in case x plus y or x minus y, it is like that. So in case p, q, r are that in multiplication format, then we can use that method of multipliers. Even some problem like case p x comma y, p equal to xy, q equal to yz, then r equal to z plus x something. So here you can see that the two terms are in multiplication, the final term in addition. So this type of problem we can use that both method of grouping and the method of multiplier. So in the same problem, in some situations, we can use that method of grouping and method of multipliers. So these things we have to be note down. These points are the very important points. In case all that x, y, z in that multiplication format, you have to use that method of grouping. In case that x, y, z in that addition or subtraction format, you have to use that method of multipliers. In case if it is combined of both the multiplication and addition or subtraction format, we have to use that both methods, method of grouping and method of multipliers. This is a very important note, you have to note down that. Then we can solve the problem by using that method of grouping. Can come to this. So first method is method of grouping. Method of grouping. What is the procedure? Procedure is that the given equation is very simple procedure. The given equation capital P, small p, capital Q, small q equal to R, which is the equation number 1. The step 1 as given here, what is the first step? Write down the subsidiary equation. The subsidiary equation is dx by capital P dy by capital Q dz by capital R. Now there are three subsidiary equations are there. This is the first one, this is the second one, this is the third. Now we have to find that the two solutions u and v. Finally we can find that phi of u comma v equal to 0. For that, choose any two subsidiary equation. We will get that, for example, we can choose that 1 and 2. So choose that 1 and 2, we will get that dx by p dy by q. So in the numerator it is function of x and function of y, but pq is that function of x, y, z. So therefore if p and q contains any z, eliminate. In case p and q contains any z, when you are eliminating that one, then this will be that only that function of x and y. Then integrate on both sides. When you are integrating on both sides, we will get that integral over dx by capital P equal to integral over dy by capital Q plus some constant C1. So from this you will get that one answer, u of x comma y equal to C1. You take this as equation number u. Similarly, next you have to choose that any other two subsidiary equations. Already we have chosen that 1 and 2. Therefore, this time you can choose that either 2 and 3 or 1 and 3. It is based on the problem. In case if you are choosing 2 and 3, then what you get? If you are choosing that 2 and 3, choosing, in case if you are choosing 2 and 3 subsidiary equation 2 and 3, you will get that dy by q equal to dz by r. So see the numerator. The numerator is a function of y and z. In case q and r contains any x, it is very difficult to solve that. That means is not able to integrate. Therefore, if q and r contains any x, eliminate. When you are integrate on both sides, you will get that integral over dy by capital Q equal to integral over dz by capital R plus some constant C2. So if you are solving this, you will get that some function of y comma z equal to some constant C2. This is, you can take that equation number B. Here we can obtain the two solutions u and v. Therefore, we can write the solution of the given equation capital P small p capital Q small q equal to R is phi of u comma v equal to 0. This method is called the method of grouping. Based on this method, we will solve few problems. First problem, solve xp plus yq equal to z. Write the solution for this. What is the given equation? xp plus yq equal to z. It is in the format of capital P, small p, capital Q, small q equal to capital R. If we are comparing this xp plus yq equal to z, then easily we can get it that xp equal to capital P, yq equal to here, z equal to this. So if you are comparing these three terms, we will get that capital P equal to x, capital Q equal to y, capital R equal to z. So as per steps, here we can see that P, Q, R contains only x, y, z. It is in the multiplication part. There is no addition or subtraction here. Therefore, we can use that method of grouping. For the method of grouping, first either it may be the method of grouping or method of multiplier. First you have to form the subsidiary equation. So what is the subsidiary equation here? Subsidiary equation is dx by capital P, dy by capital Q, dz by capital R. So if we are substituting P, Q, R here, you will get that dx by x, dy by y, dz by z. Here it is the first equation, this is second equation, this is the third subsidiary equation. So you have to choose that any two subsidiary equation here. In case if you are choosing that first and second equation, we will get that dx by x equal to dy by y. In case if it contains any z, you have to eliminate it. In case the denominator contains any z, you have to eliminate it. Otherwise, directly we can integrate on both sides. What you get? Integral over dx by x equal to integral over dy by y plus some constant c1. So we can write log x, integration of dx by x is log x, integration of dy by y is log y. The constant we can write log c1. If two terms are in log, the third term also we can write as log. Therefore, we can take it that log y to that side, log x minus log y equal to log c1. So log of x by y equal to log c1. That if you omit that log on both sides, you will get that x by y equal to c1, which is equation U. Already we have chosen that 1 and 2 from the subsidiary equation. Next you have to choose that 2 and 3. In case if you are choosing that 2 and 3 here, you will get that dy by y equal to dz by z. Continue. If you are choosing 2 and 3, dy by y, dz by z. In case if it contain any x, we have to eliminate it, integrate on both sides. We will get that integral over dy by y integral over dz dz plus some constant c2. So integrate it, log y equal to log z. When the two terms are in log, you can write log here. So log y minus log z equal to log c2. We can write log y minus log z is log y by z equal to log c2. Permitting log on both sides, we'll get that y by z equal to c2. It is equation V. So for the given equation xp plus yq equal to z, then the solution in the format of y of u comma v equal to 0. That implies, what is u here? X by y, v is y by z equal to 0, which is a recurrent solution. Is a recurrent solution. Even sometimes this may be written as, I'm writing as a note here. You can write the solution. Either you can write that pi of u comma v equal to 0, or sometimes it may be written pi of c1 comma c2 equal to 0, because the right hand side of this equation is c1 and c2. No need to write the c1 c2 in this equation in the solution. Okay, so what is c1? X by y. c2 is y by z. You can write the solution like this. This is the first problem. Second problem is, and then one more thing, here you can note down that even we can choose that already we have taken that 1 and 2, 2 and 3. Sometimes we may take that 1 and 3 also. That is, the solution is not unique for this type of problem. You can write one more note here. What is the note here is, the solution is not unique for capital P, small p, capital Q, small q equal to capital R. Sometimes we may take that first and second term, or second and third term, first and third term. So we may get the different solutions. Okay. Next one is problem number 2. Write the solution of px square plus qy square equal to z square. So write the solution for this. What is given here? Given px square plus qy square equal to z square. So that is in the format of capital P small p plus capital Q small q equal to capital R. So that implies capital P is x square, capital Q is y square, capital R is z square. What is the first step? First step is, we have to write the Lagrange subsidiary equations. The Lagrange's subsidiary equation is dx by capital P, dy by capital Q, dz by capital R. That means dx by x square, dy by y square, dz by z square, not r square, z square. dz by z square, which is, we'll take this as equation number 1. There are 3 parts in subsidiary equations. So first you take that the first and second part, you will get that dx by x square, dy by y square. Now that integrate on both sides, you will get that dx by x square integral over dy by y square. So in case if you are integrating that dx by x square, we will get that minus 1 by x equal to minus 1 by y. Even all are in minus, therefore we can write that minus c1. Similarly, second and third, if you are taking that second and third subsidiary equation, we will get that dy by y square equal to dz by z square. Integrate on both sides, you will get that integral over dy by y square equal to integral over dz by z square. We will get that minus 1 by y equal to minus 1 by z minus c2. So we will get that 1 by x minus 1 by y, 1 by x minus 1 by y equal to c1, 1 by y minus 1 by z equal to c2. Therefore, the general solution is hence the general solution is pi of u comma v equal to 0. That is pi of, what is u here? You can take this as u, this as v. So we will get that 1 by x minus 1 by y comma 1 by y minus 1 by z equal to 0. So here you have to note down one thing. Integral over 1 by x dx is log x plus c. That is the first formula. Second formula is integral over 1 by x square dx is minus 1 by x plus c. Third formula is in case 1 by root x dx equal to 2 root x plus c. These are the few problems discussed in the class. In the next class, we will discuss more problems on Lagrange's linear equation. Thank you.